First day we have learned how and why we need to learn about the computers. Introduction to computing. So we should understand the fundamentals of computing concept because we are learning, and to gain new knowledge we should have the understanding of the modern computer applications, and also we should have the digital literacy when living in the modern world. And what is a computer? So it's a programmable electronic device which can process data according to instructions, and it can store and retrieve information, and it can perform complex calculations at high speed, and it can manage input and output operations. And we have discussed about little history of the computers, so you can find this YouTube video also. And these days, computers are involved in almost all day-to-day activities. So we are communicating through social media and the bank services, healthcare, and other entertainment industries use computer. Especially, we are doing a remote learning, and we need computers to do that. And we have some characteristics of computers. Actually, one, two, three, four, five characteristics. Computer, it can process millions, billions of instructions per second. It's speed than us, and it can have a high rate of accuracy when it performs tasks. And it has multiple gigabytes, terabytes of storage, so we can store things. And computer can do multitasking. Here I am doing the presentation and recording the presentation as well. So that's possible with the versatility. And also it can automate things, it can do things repetitive, backup, virus scanning, security checks. So this is the you have AI and machine learning applications. The computers specialize to do these things, and we have a huge hype of internet computers with the internet, and also there is virtual and cloud computing and other stuff. And future trends, quantum computing, edge computing, 5G likewise, and that's it. Okay, do you have any problem with this slide? If you have, I will give you 2 minutes and I will left and join. Okay. Since you don't have any problems, we'll proceed for the other one. Right. Lecture note 0. So let's go for the next one. Lecture note 1. So check this, and if you have any problems, please let me know. Here we have learned about the applications of TEA and systems of TEA and hardware classification, right? So computer is an electronic device that can follow instructions to accept input, process the inputs, and then produce information. Computer get input, process, output. Computers are consist of hardware, software, and liveware. It's obvious. These are the main building blocks of a computer system. And we have discussed about how a input is going to process this block diagram. If you like, you can remember this. So computers are consist of hardware, mechanical parts, and software. Software is divided into two parts: system software and application software. System software further divided into two parts: operating system and device drivers. So the operating systems will discuss device drivers. It's a special type of software. Hardware, the tangible devices, all the physical things inside the computer, we call it devices or hardware, and we can classify it: input, output, process, memory or storage. Input devices convert data and instruction into electrical signals. Output devices convert electronic data to a form of output which the people can understand. Maybe a physical copy, maybe a digital copy. CPU is the brain of the computer, and it is performing all the calculations and controlling stuff in a computer. And we have the primary and secondary storage. Primary, we call it as the main memory. It's the RAM. Secondary, we can use hard disk, cloud storage, USB for that. Input device of further explanations, examples. And we have examples for output devices also. And types of outputs: soft copies, hard copies, sounds. And we have memory, RAM and ROM. And RAM stands for random access memory, and it's the most important part of the memory, and it will hold all the things temporary until you switch off the computer. We call it as volatile memory. Volatile memory. And RAM is fast, expensive. It's a short-term memory. ROM is a part of memory programmed and manufactured in time, so it can't be changed by the users. It's permanent. And RAM versus ROM. So RAM is a temporary storage. ROM is a permanent storage. And here, so some have written this in the other way. RAM, I have mentioned there's a mistake. RAM stores data in GBs and ROM stores data in MBs, right? So that here I can check whether you have correctly listened my lecture or not. So RAM is very fast, ROM is little bit slow. RAM is used every time. Here this time RAM is using. So ROM, it's only used when you boot the computer. CPU, it's a main brain, and it does all the computations and other controls. And RAM speed, CPU speed is measured by hertz. We called it as clock speed. And here we have three parts, sorry, yes, mainly two parts of the CPU, the control unit and ALU. And there's a thing called registers also. So the control unit will control all the coordination part and other operational tasks inside the computer, and the ALU, arithmetic logic unit, do all the mathematical functions. And there's a thing called registers. So it is small amounts of high speed memory. So I have given you a little example how it works. So it will it will keep small memory which will help the CPU to work fast. It's like helpers. So secondary memory, we use secondary memory for store data permanently, hard disk, floppy disk, optical disk, CD-ROM, DVD, USB, cloud. And then we have the definition for software. It's a set of instructions, and computer works according to the given instructions, and we programmers, we users, humans use computer software to handle the computer. And computer software are divided into two basic parts, the application software and system software. Application software, it will only do one task. System software will bridge the gap, will control the hardware of a computer. So system software, application software examples, and here we have comparison. System software mainly designed for managing system resources. Application software will focus on one task only. Programming of system software is very complex, but application software, it's easy than programming a system software. System software cannot run without the computer cannot run without system software. Application software can uh, easily, so the computer can easily run without application software, no need to have such. System software do not depend on application software, but application software depend on system software. Then liveware, it is human, us computers are not fully automated, we need to intervene. So we should repair the computers, we should design all the computer components. And components of the computer, the summary, we have hardware, software and liveware. Types of hardware, input, output, process or CPU, main memory and secondary storage. And types of software, application, system. Here we have some examples. Right, any problem from that? Any problem from that? You can turn on your mic and ask me.
Excuse me, sir.
Yes.
Sir, live is meaning.
Liveware, human operators,
Okay, sir.
people who work with computers.
Okay,
We,
sir.
the computer owner.
Okay, sir.
All right, we'll continue. Lecture note 2. Classification of computers. Classification of computers. So we can easily check this one. This is the easiest one. The diagram, you can easily remember things using that. Here, this one. Classification of computers. We can classify computers according to the data handled. So digital computers, analog and hybrid. So what are digital computers? Digital computers use ones and zeros or electrical signals to work with. Work with numeric or digital form. Then analog computers so analog computers we'll see here analog computers it is getting input from variable physical quantities such as electric potential, fluid pressure, mechanical. So here we have some examples for digital computers, desktop, laptop, cash registers, smartphones. Analog computers, petrol pump, it is used in scientific and engineering purpose. It is giving approximate results. It is very fast in operation, easy to graphical results directly. So you can see the result easily. Likewise, and speedometer, gasoline pump, likewise. And we have hybrid computers. So it is the combination of analog and digital. Then we can classify computers according to the function, special purpose, general purpose. So let's see special purpose, general purpose. Special purpose computers. So the hybrid computers has both the analog component and the digital things, right? Scientific applications, analog and digital. Plus analog plus digital hybrid computers. Classification based on function, special purpose, general purpose. Special purpose are designed only to do one task, particular task. So they cannot be used for other tasks like calculator, ATM machine, washing machine, cash registers, likewise. And general purpose, the laptop you use, the laptop desktop PC, like that. And size and processing power. So this is about a little bit about the history also. So we have around 4 types of computers according to the size. The largest one is the supercomputer. Then we have the mainframe, then mini and micro. The computers we use falls under the microcomputers category, desktop. And supercomputers, characteristics, large storage capacity, very expensive and very large in scale. It's for quantum physics, weather forecasting, climate research, molecular research, such things. And then we have the mainframe computers. So mainframe computers are used in banks and other financial institutions, maybe in schools, universities. And here we have some examples also. You can try them. You can see them. And also we have the mini computers, medium sized computers, mid range computers, another name. So here, okay, mainframe is the largest one, then the mini, and we have the micro. So here we have some examples. Microcomputers, low cost, affordable computers. And we have portable ones, laptop, notebooks, palm tops, wearable computers, medical devices. Then we have discussed about this. So this is the summary. So you have a separate recording also, you can watch that. So any problem with that? Okay, so since you don't have any problem of that, let's move on to the other one. Let me go to lecture note 2, 3. It's about the operating system. So what is an operating system? So operating system is a program that acts as an interface between the user and the computer hardware and controls the execution of all kinds of program. So here they have listed the programs here. Sorry, here we have them. What is the purpose of operating system? Resource manager, memory management, likewise. And sometimes they will ask, what is the meaning of operating system as an extended machine? So what is the meaning of that? This one. The operating system hides the truth about the hardware from the user and present a nice simple view of named files that can be read and written by the user. So that is the answer for operating system as an extended machine. And then, so here you can see the hardware has ugly interface, but operating system make it beautiful and make user to easily work with those things. Operating system as a resource manager. So a computer consists of one or more processors, memories, disks and printers, and wide variety of other devices. So the job of the operating system is to provide for an ordinary and controlled allocation of the above devices among the various programs competing for them. So it's managing things. It's like a manager. So there are two ways of managing resources, the space multiplexing and time multiplexing. Space multiplexing, it will divide memory or resources and then allocate certain percentage for the programs. In time multiplexing, it will give certain time to do the task. Functions here, memory management, process, device, file, security, job accounting, error detecting, coordination. And it will manage the files as well, file management. And two types of operating systems are there. We call the thing as shell. So there's CLI and GLI. GUI. CLI means command line interface and GUI means graphical user interface. So this is an example for GUI and this is an example for CLI. And types of operating system, mobile and desktop. Mobile, Android, BlackBerry, iOS, WebOS. We have MS-DOS also. It's a CLI one. Windows GUI. Here some comparison. Okay. Any problem with that operating systems? So I'm just going through. You can refer all the recordings and the lecture notes. Any problem? Let's move on to the other lecture note 4. Introduction to computing, measuring units. Measuring units. So we use memory measuring units to divide the memory. We need memory units to calculate things. So basic units of memory: bit, nibble, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, and yottabyte. Right? You need to remember this table. Right? You need to remember this one. Because sometimes in the exam we can ask. You can remember this table. And real world examples for kilobyte size, a short email, a typical photo MB size, a movie or smartphone storage gigabyte, and hard disk and other backup devices terabyte size. And some other examples. Do you have any question about the memory units? We have even discussed how to convert units also. So if someone asks to convert 1 gigabyte into bytes, how to do? So gigabyte, then here we have byte, kilobyte, byte, kilobyte, megabyte, and gigabyte. So how to convert gigabyte to megabyte? You should multiply it by 1024, and megabyte to kilobyte again 1024, kilobyte to byte again 1024. If it is 3 GB, it will be what? 3 GB, 3 GB, 3 GB. So it should be multiplied by 1025, again 1025, again 1025. So it will be 3 billion to something. So you can check it using browser also. GB to byte conversion. So here you can add 3. So this should be right. 3 right here. 1 2 3 4 5 6 7 8 9. 3 billion bytes. Right. So you can remember that conversion table. Maybe in the exam we can ask. Right. So I have included some conversions in the assignment also. So you can remember this. Right. So any problem with the memory units? All right, so let's move on to the last two, the information system and the security one. Introduction to computing, information systems. So we have discussed what is data and what is information. Data is raw facts, raw values. We can't get decisions based on the data. Information, it's a process structured data. We can get meaningful decisions using this information. And there are some characteristics of information. It's timely, accurate, and completeness. Timely, accuracy, and completeness. Information system. Information system is a system that gathers data and process data and provide facilities to take decisions. Information system, we have several components: hardware, network, software, data, people, procedures. So information system is an integrated set of components for collecting, storing and processing data. Yeah, input, process, output data for providing information, knowledge and digital products. It means it will help you to get decisions based on the information. And here we have components of information system. We have discussed here these components, 6 components, or else we can tell 5 components: people, data resources, network, hardware, software. And there's a special information system called management information system. So it's used by mostly the managers. The management information system is a type of information system used in business and commerce to improve the productivity of workers and management. So here we can use it to take decisions. Management information system. So components of management information system: people, business, data, hardware, software. So here it's a detailed description. People, the users who use the information system to record their day-to-day transactions. Business procedures, best practices. Components of information system: data, hardware, other components. And here we have types: information retrieval system, question answering system, database system, management information system and decision support system. Types of information systems. And here we have functional elements and applications. So this is the real world application. Nowadays we live in information age, and the focus on information and technology has profoundly affected the nature of society and the world of work. It means we can't avoid using information systems. We should use the information systems where necessary. So here how a person will receive information, you know these things: 5 senses: visually, orally, tactically, olfactory through smell, gustatorily means taste. And here various tier of information systems. So where we use it: in economics, politics, education, health, military. And here disadvantages, limitations of information system: you can't solely rely on the information system because sometimes it's differ from the real scenario, and it won't give perfect information to all users. Sometimes it will contain human errors, and for some questions you can't get descriptive answers. Here some other limitations. That's it, right? Any problem with the information system? Then we can go for the last lecture slide and finish the session. Okay, so let's move on to the other one. You can refer the recording also, and then again you have problems, please you can send a message in the public WhatsApp group. The last one: computer security, the most important one. What is computer security? It is protecting physical computers, data and networks from theft, damage, unauthorized access. All of three: stealing, damaging, and entering without permissions. It is important to protect your personal information. It may contain financial information, private data, and privacy. And there are types of malicious softwares. They are designed to harm or expose your data to the others. And here we have types, 5 types: virus, worm, trojan, ransomware, spyware. Virus attack and damage files. Worm spreads automatically. Trojan secretly enters as a legitimate software. Ransomware will require money to unlock your files. Spyware will secretly monitor your activity. So here the main difference between the Trojan horse and the spyware is Trojan horse, it will behave like a original software, and spyware secretly monitors. So here spyware you can't detect it easily. Trojan horse you can see the software but it is doing something else. So prevention tips: install antivirus, scan your computer regularly, avoid downloading or clicking on untrusted files. And here we have some antivirus softwares. And common types of computer attacks: phishing. It's like phishing. They will send a fake email, and when you click on the link, they will get your details. Hacking. They will do unauthorized things and access your computers. They will use your limitations. DDoS attacks. It will send many requests to a server or a website, and it will down the website or the system. And there's a thing called man in the middle attack. Man in the middle, it will secretly hear to the communication you do and secretly provide information to the other parties. And here some other prevention tips: verify email source. We will see some examples. When possible, browse HTTPS websites only, and avoid logging for untrusted Wi-Fi networks. And then here we have discussed about the password policies, how to make a strong password. So you can use 12 characters at least, and avoid use personal information, names, birthdays, and make unique passwords, and enable SMS verification, two-factor verification. And there are some privacy concerns also, how to protect your private data. So it will do following risks: social media oversharing, tracking cookies on websites, data breaches. So how to protect your privacy? So you should adjust your privacy settings in social media. Again, you can add two-factor verification. So you can use VPNs also. So here are some examples for, this is a real example for ransomware attack. Wanna decrypt, and this is phishing email, so it is not legitimate. Another one here, Mike at Microsoft, here spelling is incorrect. And this is how you prevent. And we have discussed about the password protecting rules also, so I haven't included it here. You should add upper cases, lower cases letters, special characters. Here mix of letters, numbers and symbols. So that is the best thing to avoid, to make a strong password. So that's it. So do you have any problem regarding the security? So that is the last lecture. All right. So then we can conclude the session. So if you have any problem, you can ask me.